Welcome to probability using compound events. These problems will involve the word "and." A compound event measures two events happening at the same time as a single probability. In the first example, we are flipping a coin and rolling a die, which is two different events. In the second example, we are picking two people, which is also two events. There are different types of compound events. The first is independent events. Independent events do not influence each other. That means the first outcome does not change the second outcome in any way. Since rolling the die does not change how the coin is flipped, they are independent events. When using "and" with independent events, you can find the probability of each event and multiply them together. The probability of rolling an even and landing on heads is 0.25. You may or may not be familiar with cards, but in this example we are drawing two cards. We are hoping to get two kings. In the example it says that after we draw the first card we put it back. This returns the deck to its original sample space of all 52 cards. Even though we are using the same deck, the events are independent because when the card is replaced, the first card has no influence on the outcome of the second card. Each time there are 4 kings out of 52 card deck, we multiply to get the probability of 0.0059. Sometimes the first outcome changes the sample space for the second outcome. These are called dependent events. In this example, there are 10 dancers and 5 singers. You want to pick 2 dancers. You are measuring the first choice and then the second choice. If you get a dancer the first time, that means that there are less dancers for the second choice. There are also less performers. The sample space has changed as you make selections. This is also known as without replacement. Conditional probability is used when events are dependent. The notation probability of B/A measures the single probability of B happening if A has already happened. The probability of the first performer being a dancer is 10 out of 15. The probability of the second event is 9 of 14 because there are now 9 dancers of the 14 remaining performers. To complete the problem, we multiply the probabilities of events together. The chance of getting 2 dancers in a row is 0.4288. A final example using dependent events involves drawing a king and a jack without replacement. The first king measures 4 of 52. When we go to get the second card, there are only 51 cards left in the deck. However, all 4 jacks are still there. The probability of the second card being a jack is 4 out of 51. We multiply the probabilities together and get .006.